Today we are starting our project on neuroimaging. Today we have to understand the concepts of computer vision and deep learning. As you all know, in our project neuroimaging, we have collected three-dimensional images of brain MRI. MRI, as you already understand, it is magnetic resonance images which can be taken for any human body part. In our project, we have taken MRI images from various national cancer institutes and tumor institutes where brain images are being diagnosed and they are being verified by radiologists, and those real-time images we are using for development of brain tumor detection models. Okay. So in order to do that, the basic fundamental of computer vision needs to be understood. And then you need to understand how latest technologies like deep learning can be used in order to make a successful model which can perform computer vision precisely and with highest accuracy. In order to take you there, I would like to quickly take you to our project board. Our project board, we have started our session. In lesson 1, we discussed the following. Just to give you all a quick review. So we collected the data set for brain tumor segmentation. This is collected from year 2017 to 2019, and it is hosted on my server 13.232.226.32. Anybody who is watching this session can access this URL and you will be able to access this data set for pre-processing. Now, post that, once we have got this data available, so we got the labels along with three-dimensional brain images. We are using NILearn library, which is one of the finest library for performing neuroimaging. This library is dedicatedly we can use for performing neuroimaging operations on brain images. Brain images can be two-dimensional MRI, it could be three-dimensional MRI, so you can use both. In our project, we will be considering three-dimensional images for brain MRI. Now, let's quickly go to the next segment. In the previous session, we have opened these brain tumor images, and I have also explained you all that how these brain tumors are categorized into multiple categories. So you guys understand that there is a flare segment. Then within the flare segment, you have non-enhancing tumor. Then you have enhancing tumor. You have a tumor core. So four types of segments, or you can understand 4 types of layers are there in a three-dimensional image which we need to identify. Okay, I hope this is clear to everyone. Flare is the overall area. Then you have a non-enhancing tumor. Then you have the enhancing tumor, which is increasing gradually. And then you have the tumor core, where the main problem exists. The image which you are seeing here is an image of flare, which is displaying the total tumor area in a human brain, okay, in a patient's brain. So now this is a three-dimensional image which you need to understand. You have to make a machine learning model who will be able to view these images, who will be able to identify where the tumor core is, where the tumor non-enhancing tumor is, where the enhancing tumor is, and where the flare part is. Okay. So a model needs to be designed using the concepts of deep learning. To perform deep learning well, you need to understand your three-dimensional computer vision techniques well. So for that, what I have done is I have shared a guide, a dictionary with all of you. So the dictionary I have shared with you. This is a computer vision and image processing dictionary, which you guys will be using. So let's quickly open this dictionary and let's have some references. Now, this dictionary probably contains each term which is used in computer vision. So you can keep this guide handy along with you so that you guys will be able to get any concept which is required during your image processing experience. Now, first thing which we would like to get started is to get started with three dimensions. Okay. So we will be starting with the concepts of three dimensions. And before starting three dimensions, let's quickly have a quick look about two dimension also, so that you guys will be able to relate each and everything. Okay, here. So now, just to give you a quick introduction to what dimensions are. So here, the study starts with one dimension. One dimension, as you can see, one dimension could be a signal which is represented on x-axis and it changes with time. Okay. So what you can say, let's say if you have time and it is changing with respect to 1, 2, 3, or if you have a counter like 1, 2, 3, 4, 5, or if you have a sequence of marks like from 1 to 100. So all these can be considered as a one dimension data. Okay. So wherever you have 1 degree of freedom in shape variation or motion, that is known as a one dimension technique. Okay. So in one dimension, you only have an x-axis, and this axis change with time. Okay. Is that clear? The value is changing with time or something like that. Changing with an iteration, changing with any sequence. It does not depend on any other dimension. Okay. So values or any value changing with respect to time could be considered as a one dimension value. Okay. Post that comes two dimensions. So a space describable using any pair of orthogonal basis vectors consisting of two elements. Okay. So let's say in case if you have two axes, x and y, if you have, uh, let's say if you have a value and that is dependent on another value or maybe independent from that value, but it is compared with that, you can gradually display that into a two-dimensional space. Okay, so this is a pair of orthogonal spaces which is represented to you here. Okay, so now you can consider this is a point, and this point in two dimension is represented on the basis of point with respect to x-axis and point with respect to y-axis. So when you represent any data on a two dimension, it is represented in an orthogonal space wherein two vectors will be defined. One vector will be represented on x-axis and second vector will be represented on y-axis. That is known as an image. So you can consider any image which has two dimensions, like you can consider any actor's image and you can put that on a graph and you can check back at what point the eyes are falling and what point eyebrows are falling and so on. So then you can go for a coordinate system. What is a 2D coordinate system? What is a 2D image? So when it comes to image processing, we need to understand what is a two-dimensional image. So two-dimensional is a matrix of data representing samples taken at discrete intervals. Okay, the data may be from a variety of sources and sampled in a variety of ways. So in computer vision applications, the image values are often encoded color or monochrome intensity samples are taken by digital cameras, but they may also be of different ranges with respect to what the definition says. Okay. So here you have a two-dimensional image, and any image can be represented as a mathematical matrix. That is what you guys need to understand. Okay. So you have an image. This image has to be represented as a mathematical matrix. Okay. So how you guys can extract mathematical matrix out of an image? Let's quickly have a look. Okay. So we'll quickly get back to our collaboratory file. Let's get started with collab.research.google.com. Okay. And you will be using NILearn library, which is one of the best for performing neuroimaging. So what we'll do, we'll take up some basics of NILearn and we'll represent our image in different format. So you can quickly go for NILearn reference. Okay, here is the reference on Get. So I will quickly share the link with all of you. This is the reference for NILearn library. Okay, you guys will be able to access the NILearn library modules here. Now in this NILearn, this is the reference documentation for all the NILearn functions. Okay, here. So these are the major modules which you can quickly use with NILearn library. So what you all can do, you can check back functional connectivity, automate data set fetching, how to decode images, how to perform decompositions, how to perform image processing and resampling. Okay. And how will you be able to perform load and process files of images, how to perform masking, operating regions over brain. Then you can perform multi-mass univariate analysis, multivariate. You will be able to plot the brain data, which we already had a look in the previous session. You can pre-process the time series. Followed by you can manipulate surface data. Okay, so these are some of the major modules which you can cover when it comes to NILearn. Now here, you have to perform some image processing and resampling utilities. This is the first thing wherein you can get started with matrix and all that stuff, decode, okay? All these things you can get started here. So we'll quickly get back to NILearn image, okay? And now you can see that you have a lot of options available over here. So you have the mathematical operations working on NILearn image. It could be a 2-dimensional image, it could be 3-dimensional image, it could be 4-dimensional image. A lot of things you can quickly perform over here. And these are some of the functions which you can access. So one of the best thing to get started is get started with a user guide with NILearn. So instead of directly landing up to the chapter number 5, it's always a good idea to go to the user guide and get started with NILearn. Okay. So here is the user guide reference. I'm sharing the user guide reference with all of you. User guide for NILearn. You guys need to explore this guide so that you will be able to perform brain analysis well. Okay. Now here. So here are the table of contents which you need to quickly get started. And here you have decoding and MVPA, which is prediction over the brain images, which you guys need to perform. Okay. So what you can do is you can quickly get started with the first point, wherein you can go for how to load and prepare the data for the image, how to load the data into NILearn, how to perform a simple decoding analysis over it, then how to make an estimator, how to make a model over it. All these things are available. Okay. Then you have functional connectivity, plotting brain volumes with NILearn. Then you have various usage and pipelines. Then you have all the functions available over here for the image. Okay, you can quickly get back about how to get the clean images, how to concatenate the images, how to crop the images, and so on. So there are so many things which you all can quickly use here. How to smooth the image and all that stuff. So I'm taking you to a basic script which you guys need to get started. Let me just quickly go here. Okay, so I'll take you here to the code. Just to quickly make you understand. You can also do that with another libraries also. Okay, so I've got that here. I've got certain data for brain images here, maybe. Okay, I think I have deleted that. Okay, yeah. So here I have some of the basics which you guys need to quickly understand. So here, the first thing which I need to show you is the matrix. Okay, how this particular part works. When you grab an image or when you use a two-dimensional or a three-dimensional image in Python, how will you be able to generate the matrix out of it? That's what we need to understand first. Okay. So in order to do that, we have used two libraries. One is CV2, which is a computer vision library. Another one is NumPy. Okay. So NumPy is a mathematical library, which you guys already understand. Now, post that, let's say here in the demonstration, I took a Salman Khan's image from server, but you can take any of the images which you like. Okay. And what you can do is, as soon as you read an image using the imread function, you're going to get a byte array out of the JPG or the PNG file. So let's just quickly try that. So I've gone here, images.google.com. Okay. So we'll either that would be good if we start our one of this. Okay, let's continue with the neuroimaging project itself within this script image, like when I say Salman Khan daily. Okay, so I've got this image. Let's say I'm going to save image as, call it as salman.jpg. Okay, we'll go to our project file, project script. You'll go to the files section here. You're going to upload that and you're going to grab that image. Okay, so under documents, I've got this salman.jpg file, which I've loaded here. So as you all can see, the file has been uploaded and now we're going to pre-process that. So to get started, you can use CV2, which is a computer vision library, and post that using CV2. You can use the function imread to read the data. Okay, so I'll show you a quick help on how you can quickly read any image and that will be converted into a matrix for pre-processing. So using imread function, you have to display you have to put a file name, whatever you want to use. It could be your brain images, and then you're going to get a return value. So just to get a quick description, function imread loads an image from the specified file and returns it. If the image cannot be read because of missing file or improper, an empty matrix. Okay. Now, so here you can read these types of use bitmap images, DIP, JPG files, JPG 2000 files, PNG files, web files, portable image formats like PBM, PGMP, XS. Okay. So what you're going to get in return, you're going to get a matrix in return. So let's go here. Let's quickly specify the image. So I would like to search within my directory. I'll put a tab key here and I've got a file known as, in the current directory, I'm going to read the file as Salman Khan's. That would be the name of the file, salman.jpg. Okay. So now this image is going to be represented on a matrix, and let's get the matrix up. Okay, so you have got a two-dimensional image, and that two-dimensional image, when it will be read in Python, you're going to get a two-dimensional array like that. Okay, you're going to get a matrix in fact. I hope this is clear. So for any image, you can get your image matrix, and then you can perform certain operations on it. I hope this is clear to all of you. You guys are clear with this stuff? that how an image is read and what are these image values, how we get these image values. Let me know if that is clear to all of you. Okay, great. So now, once you guys are done with that, now there are certain things like 2D points, projections, but we are focused towards 3 dimension. Okay. So what is the 3 dimension? 3 dimension is a space which is describable using any triple of mutually orthogonal basis vectors consisting of 3 elements. Okay. So 3 elements as in you're going to have 3 elements represented on an orthogonal on 3 orthogonal planes, and each orthogonal plane will represent a vector. Okay. So how does a 3 dimensional coordinate system looks like? 3 dimensional coordinate system looks similar to a 2 dimensional coordinate system. Okay. But this is compared in 3 axis, which you guys already know. This is as soon as the value increases in x-axis. This is as soon as the value increases in y-axis. And this is as soon as the value increases in z-axis. And you get a point. Okay, is that clear? So I think this you guys already understand what is 3 dimensional image. And once you load a 3 dimensional image, you can actually get its matrix also. As soon as you read an image, you're going to get that matrix out of it. Okay. Then each of your 3D object could be represented as a model. You can specify various movements, you can consider the object, you can reconstruct the object, you can perform stratigraphy over an object, you can perform structure recovery, and so on. So a lot of options are there with respect to 3D images, which you all can do. So I would really suggest you all to go through with this document and go through with all the definitions of 3 dimensions, so that you get a little idea about how these dimensions work. Okay. Now, once you guys are done with that, then you have to understand the connectedness, which is the first reference topic in the references. How we explore connectedness and how we get this connected object pixels graph. Okay. This you can quickly get back from number 1. Okay. Here, the references you have, the complete examples of this. Okay. So this is functional connectivity of images. So you can measure the connectivity, you can check symmetric matrix. Okay. So there are a lot of functions which you guys can understand. दोनों चीजें आप लोगों को explore कर दी हैं. What is a 2 dimensional set? What is a 3 dimensional set? Okay. So यहाँ पे images में हमने कुछ perform किया था. The basic examples on 2 dimensional images and 3 dimensional images. ये हम लोग with atlas plot, with brain plotting. ये ग्रास ब्रेन प्लॉटिंग का भी कॉन्सेप्ट हमने पिछले बार में किया था. तो जो लाइब्रेरी इसके लिए यूज होती है वो भी ऑलरेडी हमने पिछले सेशन में हमने किया था उसको. ठीक है. So you can make a lot of plots here using this. Then you have how you can perform decoding and predicting the brain images. That is the third segment, how to decode it. Fourth is the functional connectivity, wherein you can make a scatter matrix or a correlation kind of a matrix, which you guys have already done, in order to understand where the signals matches and what are the functional regions and all that stuff. Okay, so this is the functional connectivity part, which has to be implemented, followed by manipulating the images, putting the images onto grayscale, putting the images onto different color scales and all. So all these things we need to do. Okay. So I would like to suggest you all, you have access to this script. You have got access to here, I believe, for the neuroimaging. Yeah. So you have access access to the data set. You have got all these images. So I would like to suggest you to go through with the text available in the dictionary for 3D images, followed by you guys need to explore certain tutorial examples from here so that you can understand how to visualize the images. And I would like you all to get started with decoding of the images. Okay. So you have to start with predicting the brain images. This segment you have to get started. So you have your data, try to perform some steps over this. Once you guys are done, push your script files in the Trello cards so that I will be able to observe what all you have implemented, and then we will continue next in our next project session. Okay, so I believe this is clear to everyone. You guys need to understand the dictionary terms for 3D, 4D, and you have to get to this tutorial. Whatever functions you will be using in these references, you have to refer them back to the dictionary, and then you have to push your script in the Trello cards. That's what you guys will be doing today. So that's all for today's meeting. Get some work done over decoding the images, push your script file so that we can proceed next in the next segment. Thank you so much for being available. If you have any questions, you can raise your questions and you can send that to me on chat.